For the first example, we are going to apply this idea of what a theorem is a little bit, but the fact that we talked about reflexive, transitive, and symmetric as how we can do it with congruence. Notice, first of all, Mrs. Hochgraby, how the fact is that, trying to find my mouse. The fact is that our given is dealing with some equality, but we also have some congruence as well as where we're trying to prove congruence. So right away, I want you to keep that in mind.
Okay.
All right. So first and foremost, let's go ahead and label our picture with what we know.
I think that's a great idea.
All right. So we know that LK's length, this is saying the length equals 5. So I'm going to go ahead and put 5 for the length of LK. And JK also has a length of 5, so that's something you might be noticing what we're going to be able to do. Okay. And we also know segment JK is congruent to segment JL. Again, notice the notation with the segment JK segment length. All right, the segment is congruent to segment JL, the little tick marks. I'm going to go ahead and just write this down in my first step. So keep in mind also where we're going.
Yeah, and I noticed that we're focusing, we want to get to talking about congruence. Right now we have two segments that are congruent, but really because they're both 5, we know that JK and KL are also both 5. Okay. Because we know that they have the same measure.
Okay.
So maybe the first thing I need to do is talk about how those two are equal, because they equal the same thing. We know they equal each other. That's that transitive property, right?
That makes sense.
Or I could use some substitution to say that LK and JK are equal to each other.
And you said, Mrs. Hochgraby, you said you could use transitive because remember, transitive is one of those properties that works with equality as well as congruence. Now that we know this, and since LK and JK both equal the same thing, we can set them equal to each other. Now you also mentioned...
I could have said substitution because if one equals 5, I could put that in place of the 5 in the other one.
Okay.
So yeah, okay, I'm going to say that. And then if I know that they are equal, I also know that they're congruent.
Oh, now question, why are you thinking we need to change this to congruence? We say they're equal. Why do we say congruent now?
Because I noticed that I want to be able to talk about how LK and JL are congruent. And I already have a JK in both the statement that I started with in my given and then also in this new statement that I made. And so I'm thinking the transitive property, but I know that I can't put together an equality and a congruent statement to make a new statement. I have to have them either both congruent or both equal.
So stick with the same symbol. You gotta, if you're gonna be using these properties, you have to deal with congruence together and equality together. So in step 3, what do you want me to write?
Let's write that segment LK is congruent to segment JK.
And why?
And that's definition of congruence. When I take something and say it was equal, now it's congruent, and that also works backwards. If it was congruent, it's now equal. That's just the definition of congruence that allows me to do that.
And I like that you said it's backwards because definitions works forwards and backwards.
Exactly.
Awesome. All right, we're not done. Now, backtrack. We've used the first part of the given to say this. We've used this to say that. Now we still gotta use this part of the given, and we have this still.
Okay. So I am looking at those, and they both have that segment JK in common. So if two things are congruent to the same thing, they're congruent to each other. So I think we can state that LK, segment LK, is congruent to segment JL, and that is the transitive property.
And we can use transitive property now. We learned that today with the fact that because it works with congruence as well.
But I couldn't say substitution because that's a property of equality.
Yeah, substitution is talking about substituting one value in for another. Transitive is works for both. It's kind of that universal thing. Now, did we finish it?
Well, that's what I was asked to prove, so yeah, we're done.
We're done.
All right.
Awesome job. Good job.
Well, thank you very much. Now, looking at this next one, here we're given, and we've got our pictures a little bit different. We've just got some segments that are kind of pieced together. We're given that segment AB is congruent to segment BC. So what's the first thing I should probably start doing?
Let's label with the tick marks.
Sounds great. Anytime you are given something, let's mark it on our picture. We're also given that segment BC and CD are congruent. So what am I going to do here, Mrs. Palermo?
Well, if segment BC already has 1 tick mark, segment CD is also going to have 1 tick mark.
Wonderful. Okay, and we know that AB is 3x minus 1, and that CD is 2x plus 3. So I'm just taking all that given information and marking it in my picture.
Makes sense.
Now, look where we're going with this one, Mrs. Palermo.
So it looks like, while you're writing that, I'm looking back at the given, and it looks like we're trying to show that AB's length is 11, and I look back at the given, and all I know is AB is represented by lengthwise is 3x minus 1. So we're going to have to maybe figure out what that value of x is somehow.
Yeah, in fact, that's what we're proving is the value of AB is 11, so we're going to need that value of x to be able to get there.
Okay.
Okay, so let's start with just what we're given. What do you notice are the values that we're looking at in this given pieces of information?
Well, I'm noticing the first part of the given is dealing with segments that are congruent. And then the other part that you just underlined is dealing with equality. So I got to remember, I'm dealing with congruence and equality, so I'm going to probably have that little switching around where I have to convert it from congruence to equality.
Absolutely.
Because of that.
Right. And what do you know about AB and CD? Do we have a statement right now that talks about those two?
Well, we don't, but we do know that segment AB and both segment CD are both congruent to BC. So could I just say AB, that segment is congruent to segment CD?
Sure. Why can I do that?
Because transitive works, again, the fact that two things are both equal or congruent to the same thing, they're congruent to each other. Now, what about substitution?
Again, we can't use substitution when we're talking about congruence. That is only for equality.
Okay.
Okay, so now I know that AB and CD are congruent to each other. And guys, a lot of the times in these proofs, these things are going to be very obvious to us. We're not doing rocket science here. We are just really doing some basic geometric proofs. The idea, though, is that you need to have stated that before you can use that idea that they're congruent before I can go on. Okay, so now we know that these two are congruent. Not just because of the picture, but because we've made the statement.
We've stated it. Okay.
Okay, so now what's the next thing? If I know that they're congruent, what else do we know?
Well, can I just go ahead and put 3x minus 1 in for segment AB?
Good question.
Like substitute that in?
Can we substitute into a congruent statement?
No, only equality.
No, only equality.
Okay, so
we've used this and we've used this. We've put those two together to make our new congruent statement.
So I can't substitute yet.
But we can't substitute yet.
But I do know, the only thing I really know from that congruent statement is I know that they're equal too.
Exactly.
Which I can then substitute.
So let's do that.
So segment AB's length is equal to CD. And those are the lengths. Good.
Exactly.
Okay.
And what was our reason there?
Definition of congruence. And guys, you're going to see that reason a lot anytime you go from congruent to equality or back.
Exactly. All right. Now, I'm just starring the ones that we've already used. We still have not used parts of our given, but notice that now we have an equation. You wanted to substitute before, so guess what we can do now?
I can substitute now. So
Absolutely.
I'm going to put that 3x minus 1 in for AB, and then the 2x plus 3 in for CD.
And if it helps, it is perfectly okay to kind of show that work on your proof, if that helps you guys. If it makes more of a mess and you're neat freaks and it drives you crazy, you don't have to do that.
Yeah.
But sometimes it does help to just to see it.
Kind of a visual.
Absolutely. Now, what's the reason?
I substituted.
Awesome. Okay. From here, we have now used all of our given. We've used all of these statements so far. We're now at this new statement. But what do you notice we have?
I have an equation. Algebraic equation
Absolutely. Here. And you love equations. What can we do with this equation?
All right. So the goal is to get x by itself. So I would say go ahead and subtract 2x on both sides. So
okay.
I get x minus 1 equals 3. So that reason would be ESPO. And so we're going to use the property of equality since we're trying to solve an algebraic equation.
And since now we're in equations. Okay, so now what? To get x by itself?
Add 1 to both sides.
So x would equal
4. So it would be APO.
Because we added the exact same thing to both sides of our equation. Okay, am I done? I solved for x. Do you think we're done?
No, because I got to find the length of AB. Or not find, we have to prove that AB's length is 11.
Okay.
So in order to do that, I have to substitute again. We've done this before. Let's put 4 in for x. But I only want to find what AB is. So I'm going to put it in for the x in the AB. So I would say AB equals 3 times 4 minus 1. And that would be substitution again.
Wonderful. And I'm still not quite done yet because I don't have a statement yet that says that AB equals 11. But what do you know?
I could just kind of simplify that down and say AB is equal to 11.
And that reason is just
Simplify.
simplified. And simp is okay for simplifying.
Perfect.
For that too. All right. Notice, guys, that on that one, you do need to make sure that your final statement is that AB equals 11. But I couldn't just step 7 have said AB equals 11 until I showed that I substituted that in. That's important.
All right. Next example. So we got some more segments. That's kind of the common trend here. It says X is the midpoint of segment MN. So we're going to kind of talk about that. Not any labeling just yet, but I think probably Mrs. Hochgraby's got an idea what this is meaning.
I do have an idea.
So I'll come back to that. We know MX is equal to RX, which is talking about their length. We can show equal lengths as well as congruent lengths by doing little tick marks. So MX is equal to RX. I'm just going to go ahead and start writing this down.
Okay.
And while I'm writing this down, keep in mind where we're going. We're trying to show this length XN is equal to the length RX. So just keep that in the back of your mind.
Well, as while you're writing, I'm thinking right now, we talked about midpoint before. And midpoint, I know we always, the first thought is it's the middle point. But the definition that we learned was that when we've got a midpoint, it divides that segment into two congruent segments. And I do want to stress, guys, that make sure you say congruent, not equal, because that definition does state congruence. Most definitions state congruence.
Yeah.
But not all. We'll get to some.
And guys, eventually, as the year goes by, you're going to see more congruent proofs versus equality. You're not going to see equations very often as we go through the year. All right, so if you know X is the midpoint, now it's only the midpoint of segment MN.
Okay.
So you said it's going to divide a segment into two congruent segments. So what can we say?
So we could say that segment MX is congruent to segment XN.
And my reason?
That would be the definition of a midpoint.
Good.
You'll use definitions a lot for your reasons.
Yes, very popular. Especially right now, since we don't have a lot of other reasons yet.
Yes.
So segment MX is congruent to XN. Now notice this is already with one tick mark, so XN can be
marked with one tick mark also.
Tick mark as well.
Okay.
All right. Now
I noticed, so we've used that first part of our given.
Okay, so we've used that.
We haven't used the MX and the RX yet. But I do notice that both that second part of the given and the new statement we made both have an MX, but one's an equals and one's a congruence. And I'm getting the hang of the fact that we need to make sure that they're the same thing first.
So would I need to change this to congruence, or do you want to change this to equality?
Well, looking back at what we're trying to prove two things to be equal. So maybe to save us a step later, let's go ahead and let's change the step 2 that we just did into an equality statement.
So we could say MX is equal to XN.
And that's the definition of congruence again. Okay, now I have an MX in common in both that step of the given that I haven't used yet and in my new statement 3. So because RX and XN are equal to the same thing, they're equal to each other. Okay. So now I'm going to go ahead and state that XN, and I know I want to start with the XN because that's the way they asked me to do it in my proof.
Yeah.
So XN is equal to RX, and that reason, I would think transitive property on this one, but I could use substitution on this too, right? Because it's equality.
Yep. Transitive works because that's that kind of universal one, since like you said, XN and RX both equal the same thing. But substitution works, let me just kind of show you visual. We could put XN in for mx, and there's where you're getting the equation. Now, I like what Mrs. Hogravy said. She's like, I want to start with xn first. What if I had stated, I'm just going to write this off the side, what if I had said rx is equal to xn in this step instead? What would I have had to say after?
Ooh, that is the symmetric property that tells me I have to flip the order of them.
So if I didn't notice that, which is no big deal, then I could rewrite it and then just use symmetric property.
So that would just add one extra step to your proof.
Yeah, which is no big deal, but, you know, it's nicer to get finished sooner.
Exactly. So however they ask you to do it in your the proof statement, it has to look exactly like that in your answer, right?
Exactly.
Okay.
And we're done because we got the proof part as the final result.
All right. Now, this last one, they've given us that segment RT is congruent to segment SN. So I'm going to go ahead and mark that. And since RT is more than just a little part, I'm going to go ahead and just say RT, that whole thing, and give that the congruent mark, is congruent to SN. That way I know it's that whole segment.
And I like how Mrs. Hogravy is labeling that, because I've noticed some before in chapter 1, some of the students having issue labeling congruent segments, especially when it's overlapping some others. So just kind of careful with that.
All right, looking at this one, Mrs. Palermo, look at where we're going. What are we trying to prove?
Well, we're trying to prove those two smaller ones, that segment RS and that segment TN are congruent to each other, which, you know what, this kind of sounds like a proof we've done before, but the reason why I know it's a little different is because there's congruent symbols, whereas before is everything was equality.
Exactly. So let's think back to what we did before. Okay. When
it's been a while.
It has been a little while. When we were given the larger segment, but we haven't established those parts yet, do you remember how do we break up a segment into its parts? There's a postulate we learned.
Great hint. Well, because I need to say something about RS, I would say, well, RS and ST added together, so plus ST will get you that whole segment RT's length.
Okay, and notice I didn't put the segment bars because we're talking about their measures.
And that's segment addition postulate, so SAP.
Wonderful.
And I've got to do the same thing for the other segment, and I'm just going to do it in the same step since it's dealing with segment addition. So I'm going to say ST plus TN is equal to SN.
Loved it. And you're right, because they have the exact same reason, we'll keep them in that same step. One doesn't depend on the other one.
Okay.
Okay, now, look at what we were given, because we haven't used that yet.
Nope.
But what's weird about that right now compared to what we've got?
The given deals with congruent statement, and the step 2 deals with equality.
So what do you think we're going to have to do here?
Well, and I noticed the proof is with congruent. So can I just change step 2 all to congruence?
Can you add congruent segments? Can you add pictures together?
No, I guess that doesn't make any sense.
No.
Okay, so
good thought though.
Let's do the given. That we can change that to equality. So we can say RT is equal to SN. And again, the reason why we're doing this is because we need to be, if we're going to use step 2 at all in our proof, we have to have everything change over to equality for right now.
Exactly.
That's definition of congruence.
Lovely.
And, okay, so now I'm thinking, I haven't used step 2. I think I'm going to I'm going to replace the RS plus ST in for RT. Can I do that?
Sure. So you notice that RT is equal to all of this stuff.
Yes.
So I can replace that RT with it.
And then I'm going to do the ST plus TN in for SN.
Because we know that we already have what SN equals, so we can, what do we call that?
Substitution.
Absolutely. Okay, so now we're going to do some substitution. So RS plus ST will now equal
ST plus TN. And that, again, is substitution.
Okay, what do you see now?
Well,
so we've used, I'm going to mark down. We've moved this, used this, and used this. So we're
just working with that right now. And I'm remembering where I'm going. I'm trying to show the segment RS and TN are congruent. I'm noticing in that particular equation, ST is the same on both sides. So let me just get rid of that by subtracting them on each side.
Okay, so if I subtract And if you wanted to write that just to see it for a second, if I'm subtracting an ST from both sides, what are you left with?
RS equals TN, and since I subtracted both sides, that would be SPO.
Lovely. Now, is that what we were proving?
No, because we're trying to prove congruent statements, but we're almost there. If I can just say segment RS is congruent to segment TN, and that's because the definition of congruence.
Awesome.
So we had to switch from congruence to equality, and then we had to switch from equality to congruence.
Right, but on this one it was important to first get it to that equality because we had a larger equation that you can't put in terms of congruence.